Okay, I'm going to do a very brief example on how to set up these specimens for the compliance calibration tests. So you'll see this is for the size 3. You'll see 3 marks here, each corresponding to a different crack length. So you set up the beam on the rollers so that it is on the appropriate crack length. And then you'll come over to this guy. Turn this on, we're in position control. So now we can actuate the fixture head so that we're pretty close to the beam. We're going to, let's adjust this, make sure we can view the load is tracking so we can see what the actual load is. And then we can go to check this one, see it's displaying min. Let's go here, make sure we're tracking that as well. From a previous test, we've suppressed the output of the displacement. So we're going to hit this and for position, suppress, and turn that off. We'll suppress it later. Okay, then what I like to do is go over here. We need, since we're running this quasi-statically, we need to run this XY file. Should pop up. Not that, this one. Okay. Then what we have to press is this arrow here, and that shows the graph developing in real time. All we really have to do is adjust these offsets. And we can make sure they match to correspond with our load and position. So first, what you have to do though, make sure the file path is saved to where you want. So in your file, say you're saving it here, drop it down, copy this, and paste that guy in here, and then write your file in, say test, for example, .txt. Boom. And then position should be 0, or the displacement should be 0. I'm sorry, load should be 0. That's pretty close, so we'll match that. Not quite there. How about that? Yep. So we match these. Now the load is 0'd. Then we're going to come over here. Might reset this graph. Reset the graph. And come over here, still in position control. Use the actuators. We're going to move this down very slightly. Boom. There you can see the load changing now. What I like to do is go to load. I like to do a minimum load go to of 30 newtons, negative 30, enter. Should pop to 30 newtons, right on there, it'll look good. Then what I like to do is zero out the position at this point. So to set up under the position, then we'll go to suppress current. So it starts to blink, the position changes. Then we have to do, that's good, okay, it looks good. We come back here, and then we need to change the position offset so it matches. I think it's 0.0085, say. And now the position is matched too, and our load corresponds. Reset the graph. Then to save the file, press on. Okay. There's our file that was made. It's saving right now. Then we just have to run this, make sure we're in our desired controller. So for us, we need to be in position. So position, I'm going to press immediate. That just brings us to position. Check our waveform. This sees what kind of load we're using. So we have a ramp load, negative 5 millimeters, 0.003 millimeters per second. We're good to go. And like, for example, we're on 35 millimeter crack length. Press start. You can see the load starts to increase. Excellent. And then you can see, well, this will start to move. This is plotting the load versus displacement in real time. But it moves pretty slowly, so it'll take a little bit for it to get there. And then you monitor this until it reaches the appropriate load for your compliance calibration test. So there it goes. You can see some of the previous tests. This is kind of my naming convention. Specimen number, crack length, and the associated load value that we go up to. So, perfect.